In this video, I'm going to be talking to you about distance and displacement. So really what I'm going to be doing is going back to these familiar topics of position, velocity, acceleration, and adding in the new thing that we have, which is the fundamental theorem of calculus. So, a couple times ago we learned that the integral from a to b of f prime of x dx is equal to f of b minus f of a, which basically means that we can find an integral, the area under a curve, by computing the net change in the antiderivative. So if I was to apply this to the position, velocity, acceleration scenario, I could say that the integral of velocity between two time values is the change in the antiderivative of velocity is position. So I could say that that's going to be change in position, like a definite integral of velocity. And we'll say this is change in position, but we'll also define this as displacement. Okay. Now I also need to define something else for you, which I don't remember if we talked about at the beginning of this course or not. Probably we talked about speeding up and slowing down, but I don't know if we talked about speed itself. So I'm going to define speed of an object. And this is kind of assuming the motion along a line scenario. Speed is equal to the absolute value of velocity. Now, eventually in this class, we will let the object break off of just a straight line and move around in two-dimensional area. And speed is still going to be the absolute value of velocity. It's just that velocity is going to become a vector, and we're going to have to remember how to take the absolute value of a vector. Now, the other thing I need to tell you about today is total distance traveled. And I could go in and give a whole long-winded explanation of why it's this integral, but I think I'm just going to kind of give it as a definition. And if you're not really understanding why this is giving total distance, well, then just come talk to me and I'd be happy to clear that up for you. So I'm going to say that the integral from two time values, so from time 1 to time 2, of speed, that gives the total distance traveled. Right, total distance. This is like the odometer on the car. It doesn't care if you're going north or east or forwards or theoretically backwards, probably not. It just thinks of everything as moving forward. How far did you actually go? And so that's where we're just going to take velocity, take that negativity away from it, and just keep adding that up. And I'll have some examples of that. Now, the last thing I need to tell you before we do some example problems is how to run an integral on the calculator. Okay? So what we need to do, we need to be able to compute a definite integral using technology in this class. So the integral from a to b of f of x dx, on one hand, it's both for TI-83s and TI-84s, it's math 9. So I'll just show you for a TI-84 right now, you would hit 9, and it'll give you something that we could compute. And I think I'll just, show you how to do that. Integral from 1 to 2 of, let's say, x squared, because then we'll know that'll be 8/3 minus 1/3 is 7/3, I think. So what's going to get 2 and 1/3? Yeah, 7/3. Okay. If you are working with a TI-83, you will need to know the syntax. I'm going to write that in there. Right? Okay, so you're going to hit math 9, and instead of that nice integral symbol, it's just going to tell you f in int. So just like that. Okay, it's going to look like that, and I'm going to type in the function I'm interested in. For example, I just did x squared. You hit the comma, which is right here below sign and above 7. Comma. Then we're going to press x to let it know that x is the variable I'm integrating with respect to, and also I'm going to let x run from a to b, right? Because I pushed comma, and then I'm going to do 1 to 2 because that was the one I had done before. Comma 1, comma 2, and then you press enter and you get the same thing. It doesn't matter. It's just an older operating system. This is how I learned how to numerically integrate, right? And there's nothing wrong with that. Okay, now let's do an example. So 2018 Calculus AB free response number 2. Some require the use of a calculator, as do all free response number 2s. Okay. because the first two problems are calculator and the last four are non-calculator. Okay, particle moves along the x-axis with velocity given by that equation. Well, the thing is, if I'm gonna be using this a couple of different times, I'm going to need to plug that into y1. And so it looks like I was doing some other type of velocity scenarios earlier. So 10 times the sine, and as soon as you hit that sine button, you need to make sure you're in radian mode. Just throwing that out there. Of 0.4x squared, okay, divided by x squared minus x plus 3. If you don't use the fraction bar, be sure to use parentheses around the denominator of the fraction, else you're going to get something completely different. All right, and that's my velocity. I've put that into y1. Find the acceleration of the object at time t equals 3. Well, we know how to get acceleration from velocity. We take the derivative. So I'm going to say the acceleration at time 3 is the derivative of velocity at time 3, and I'm going to let the calculator do that work. Right? We could do the quotient rule on that with the chain in the numerator, but we don't want to. There's no point in that. Okay, so I'm going to say math 8 to run a derivative. We've done that already, and just to remind you, in case you're a TI-83 user, we said we give it the function we're taking the derivative of, a comma, the variable we're taking with respect to, and the x value, or the independent variable value that we're interested in. Okay, we do that, and we get negative 2.118. And I just want to point out that here, this is a really important step. We're showing the reader that we are getting this number, we're obtaining it by taking a derivative of the given velocity function and plugging in 3. And that's important, right? We need to have that. Find the position of the particle at time t equals 3. Okay? Well, that's where we're going to use a definite integral of velocity. So if I integrate velocity from t equals 0 to t equals 3, that would be equal to the position at time 3, which is what I'm hoping to find here, minus the position at time 0, which is negative 5. Okay? So I'm going to say that x of 3 equals negative 5 plus the integral from 0 to 3 of velocity. And that's going to be a job for the calculator. So I'm going to go over here. I've gone back into math print mode, so I'm actually using a TI-84 now. So I've got negative 5 plus math 9, 0 up to 3. Okay, velocity is what I'd stored in y1, getting that from the F4 menu. With respect to time, which is x in this case, and that's negative 1.760. Okay. Part C. Ooh, it's going to be tough to do those interpretations in that small of a space. Let's see. I've got a pencil right here. I don't know how thick the lead is. I don't usually have a rough time with some of these. 0.7, that's probably be thick enough. All right. 0 to 3.5 of v of t dt equals something and represents the change in position. If this were an actual free response question on an actual AP exam, I would recommend much more verbiage than that, maybe even with some units, but I'm not going to have room to put that on this in these boxes here. Okay, the integral of the absolute value of v with respect to t, that is giving the distance traveled. Okay, so that's total distance traveled. Okay. And we can do that using the calculator. I'm going to pull up the same thing, except I'm going to call that 3.5, and then I'm going to delete that negative 5 part. And that's 2.844. Yeah, I knew that was going to happen. It's okay. All right, and then the integral of the absolute value. Okay, we can't just insert an absolute value around something, unfortunately. And so what I'm going to do is I'm just going to go back, get the absolute value from y2, which I only recently learned about, and I will throw in 1. Let it think for a second. And 3.737. Okay. A second particle moves along the x-axis with position x2 equals t squared minus t for 0 to 3.5 interval of t. At what time t are the two particles moving with the same velocity? Well, if x2 is equal to t squared minus t, then the velocity of particle 2 is going to equal 2t minus 1. So I need to know, where is 2t minus 1 equal to the v of t that they gave me up in the statement of the question? So I'm going to go over here, and I've got this in y1. In y2, I'm going to put 2t minus 1. They told me that I should only care about t between 0 and 3.5, and you can't see it because there's a hole punch, but there was a 0 there. And so I'm going to set the window to 0 to 3.5. I'm going to graph the thing. It's graphing pretty slowly. Looks like it's one. Oh, that could be troublesome. Whoa, I don't know why that is happening. Consider me confused. Looks like it's graphing an inequality. What's going on here? Oh, sure enough. I'm not really sure how that happened, but it did somehow. Okay, so we're just going to do the regular line, and we're going to let those intersect each other. And I'm going to zoom standard so that, okay, that's the mistake there. That's why they wanted you to only graph on 0 to 3.5. It's all right, though, because there's the line there. It intersected, and so I'm going to ask the calculator for the intersection between the blue curve and the red curve, and it's going to tell me that that's at 1.570 or 1.571. We can truncate, we can round, just as long as we are accurate to 3 decimals, we're happy. Okay, so t equals 1.570. Okay. And again, the justification, it doesn't look like much, but showing the equation that I solved using the calculator, that's really important. Okay. And that's the time where the two particles are moving with the same velocity. All right, let's look over on the back, and let's do example 2, which is a no calculator problem with kind of the same considerations. Okay, we've got a position of particle P and a velocity of particle Q. Okay. When is P moving to the left? Well, that would be when the velocity of P is negative. Okay. But I need to say velocity of P equals the derivative of position P, and that's going to be, you know what, I'm not going to be able to fit that there, so I'm just going to a little wiser here. I'm going to say that that's going to be velocity P is going to be 1 over, because the derivative of log of a thing is 1 over that thing, t squared minus 2t plus 10, times the derivative of the inside, which is 2t minus 2, which I can put those together and say that's 2t minus 2 divided by t squared minus 2t plus 10. Okay. And if I want to know where this thing is negative, I'm going to say b squared minus 4ac. Oh, okay. This denominator is never equal to 0. Okay. In fact, it's always positive because it's positive when t equals 0 and has no sign changes because it has no zeros because of, if you try to do the quadratic formula, it's going to pull back complex numbers. We don't want that. So I know that as this thing goes, the fraction will go. So I'll say that that has a 0 at t equals 1. So I'm going to plug in t equals 0 to figure out what is the sign of velocity of P. When I plug in t equals 0, I get negative 2 over positive 10 is a negative number. And when I plug in something bigger than 1, like, I don't know, say 100. 200 minus 2 is 198. This thing is always positive, but you could check, if I plug in 100, I get 10,000 minus 200 plus 10. Very positive. Positive over positive is positive. And I'm going to say it's moving to the left when velocity of P is negative, which happens to be when t is less than 1. Okay. All right. When are P and Q going in the same direction? Okay, so I'm going to need kind of a sign chart for B, or for Q. So on the other hand, t squared minus 8t plus 15, I can factor that. And that's t minus 5 times t minus 3. Okay, I can sketch the graph of that velocity function. And I can say it looks like that. That's 3 and that's 5. Okay. So to make another sign chart, it would be like that. And that's 3 and that's going to be 5. So velocity of particle Q went from positive to negative to positive. So I'm going to say positive, negative, positive. And so I'm going to have overlap here between 1 and 3, right, because they're both positive. And then I'm going to have to extend my t-axis for this one. But it's still positive all the way out there. So when t is greater than 5, that will also be a time when the objects are moving in the same direction. And 0 to 8 is kind of the bounds of time in this situation. So I'm going to say for part B, VQ and VP have the same sign for 1 to 3 and 5 to 8. I'm going to need some new paper. Find the acceleration of particle Q at time 2. All right. Is Q speeding up or slowing down at t equals 2? And so I'm going to actually scoot up there. So AQ of t is equal to the derivative of VQ. Well, that's nice. That's 2t minus 8. Okay. Acceleration of object Q at time 2 is going to be 4 minus 8 is negative 4. Okay. If I want to determine if an object is speeding up or slowing down, that was just a stray mark, I need to also consider the sign of the velocity at the same time. So I need to say velocity Q at time 2 is going to be 4 minus 8 times 2 is 16 plus 15. So I've got 19 minus 16 is 3. Okay. So since V and velocity and acceleration, they have opposite signs, I'm going to conclude that, okay, since AQ is less than 0 and VQ is greater than 0, the object is slowing down. That was part C. Part D is going to be find the position of Q the first time it changes direction. Okay, so Q changes direction at time 3 and at time 5. So I need to find the position of Q at time 3. Okay, so XQ, not really equals, I'm going to say of 3 equals what? That's the big question. So I've got the position of Q at time 0. So I just need to integrate from velocity Q to figure out the difference in position of Q at time 3 and at time 0. All right, so I'm going to have XQ of 3 is what I'm hoping to find. XQ of 0 is 5. So, and then that's 3 VQ dt. So what I'm going to need to do is I'm going to need to add 5 to both sides, and I'm going to say the position of object Q at time 3 is 5 plus the integral from 0 to 3 of velocity Q dt, which is going to be 5 plus the integral from 0 to 3. VQ is t squared minus 8t plus 15. And we know how to run this integral. It might take a few steps, but we can do it. Okay, so this is going to be 1/3 t to the third minus 4t squared plus 15t, right? I just anti-differentiate, add 1 to the power, divide by the new power. Add 1 to the power, divide by the new power. T to the 2, 8 divided by 2, add 1 to the power, divide by the new power. Okay. and we're going to let t run from 0 to 3. So this is going to equal 5 plus, when I plug in 3 to the 3 is 27. 27 divided by 3 is 9. Minus 4 times 9 is minus 36. Plus 45. Oh, yeah, okay, I was going to say, I thought it was minus 9. I wouldn't expect this integral to come back 0. But then when I plug in 0 for these t's here, I'm going to get 0, 0, 0. So I'm going to be subtracting 0. And that's going to be the position of the object at time t equals 3. In the interest of time, I'm just going to move on. Okay, example 3, 2016. Calculus AB free response number 2. Takes a calculator. All right, we're going to plug that into y1. And 1 plus 2 sine of, even put the fraction bar in, t squared divided by 2. The particle is at position x equals 2 at time t equals 4. All right. And then they're going to ask if it's speeding up or slowing down. So I'm going to do part A on a post-it note. All right. So I'm interested in considering the velocity at time 4 multiplied by the acceleration at time 4. Right? If the product is positive, it'll be speeding up. If it's negative, it'll be slowing down. So I'm going to say that's v of 4. How am I going to find acceleration at 4? I'm going to take v prime of 4. I'm going to be taking their product. So I'm going to find v of 4. I've already got it in there. I'm in radian mode. I'm good to go. I'm going to call in y1, plug in 4. Okay. Then I'm going to multiply by, call math 8 to get a derivative. And I'm going to plug in y1 at the time when t equals 4. And I'm going to get negative 3.467, which is a negative number. Since the product of v and a is negative, I'm going to conclude that it is slowing down. All right, find all times t in the interval 0 to 3 when the particle changes direction. Justify my answer. Okay, v of t changes signs at t equals, I'm pretty sure there's going to be one. I'm going to graph this thing on the interval 0 to 3, so I just know what I'm looking for. And I'm hoping to see a sign change. And I actually know I'm going to see 2 because I've graphed this thing before. I've done this lesson a couple times. And, oh no, only 1. Hold on. Type that in right. 1 plus 2 sine of t squared divided by 2. Maybe I was thinking of a different problem. Anyway, there it is. That's the time it changed sign, so I'm going to calculate that 0. I'm not going to say that it's changing direction because these are the zeros of v. That means it's at rest. That doesn't mean it changes sign. Or that changes direction. So I'm going to say t is 2.707. The justify my answer is v of t changes signs. That's all you need. Find the position of the object at time t equals 0. Okay. That one's going to be kind of backwards in time, but we can still deal with that. If we have a position at time 4 and we want a position at time 0, we'll just integrate from 0 to 4 velocity. And that's going to be the position at time 4 minus the position at time 0. Okay. But we already know that the position at time 4 is 2. Okay, so if I'm solving for x of 0, I'm probably going to add over here and then subtract that integral. Right, and then I'm going to come over here and do that. 2 minus math 9, integral from 0 to 4 of velocity I've got in y1 with respect to time. And I get negative 3.815. Okay, so we can find a position that way. And then part D, the total distance traveled by the particle from t0 to t equals 3 is going to be the integral from 0 to 3 of the absolute value of v of t dt. That was kind of the new thing that we learned today, how to find a total distance. So I'm going to integrate math 9 from 0 up to 3, math absolute value of y1 with respect to time, and it's thinking. These take a while. 5.301. And I think that's all I got for you.